Ever stared at a blurry food photo and wondered, is that a pizza or a sandwich? Or did I just snap a taco or a burrito? These real-world ambiguities are the bane of AI image classifiers. Today, we're exploring a breakthrough technique called SPFF, Stochastic-Based Patch Filtering, that's revolutionizing how AI tackles this exact problem. Let's dive into the science behind it. Why is food image classification so tricky? Imagine a pasta dish. Toppings vary, lighting changes, angles distort. Traditional models get bogged down by distractions, like background clutter or random objects, missing the critical features that define the dish. This leads to errors: a pizza mislabeled as a sandwich, a taco mistaken for a wrap. The challenge: teaching AI to focus on the essential visual cues while ignoring the noise. Enter SPFF. This method doesn't analyze the whole image at once. Instead, it breaks the image into tiny 16x16 pixel patches. Think of them as puzzle pieces. Each patch is converted into a mathematical representation called an embedding, which captures its core visual features. Then, SPFF compares these patches to a class-aware embedding, a statistical summary of what the target food category should look like. By measuring similarity, it assigns a probability to each patch, filtering out those that don't align with the category. But here's the innovation. SPFF uses stochastic filtering, meaning it introduces controlled randomness. Imagine rolling a dice to decide which patches to prioritize. This probabilistic approach prevents overfitting, where models memorize training data instead of learning general patterns. By allowing the model to explore multiple possibilities, SPFF avoids rigid one-size-fits-all decisions. It's like giving the AI a creative lens to discover hidden details that might otherwise be overlooked. The results: SPFF outperformed state-of-the-art methods on 3 major food datasets: Food-101, Food-172, and UECFood-256. Visual analyses revealed it actively prioritizes the most discriminative features, like the cheese texture on a pizza or the tortilla's shape in a taco. This precision isn't just academic. It's a game-changer for real-world applications, from restaurant recommendation systems to automated food safety inspections. So what's the takeaway? SPFF isn't just another tweak to existing models, it's a paradigm shift. By combining localized analysis with probabilistic reasoning, it addresses the core challenge of real-world image classification, distinguishing signal from noise. As AI continues to permeate our daily lives, techniques like SPFF ensure our machines don't just see the world, they understand it.